numbers and what will be like a story the way you see it. So at Lenaxon University, the computing department wants to analyze student performance data after a class test. So you have been asked to write a program that helps instructors to calculate the basic statistics. So they're saying, write a program that, number one, prompts you to enter a number of students as an integer. Now remember I was telling you that don't try to answer the whole question at a go, because each step to answer gives you marks. So for the case of this one here, let me say I will come here, right click, new file, so just say student performance. Whether can you see behind? Hey, let me see. Hey, what do you know? Better? Is that better? Alright, so the very first part of the question here is asking us, the program should prompt you to enter the number of students as an integer n, and that number must be greater than 0. So, the very first thing, maybe I say yeah. Your main function. So that's where we begin from. So you all remember, because don't remember, you're trying to get input from the user, you want to use a what? Which type of function? Function. So very first thing, first of all, try to make your work nice. So we shall first of all print f. Enter the number of students that dominate. So for this, the thing I left out is I'm going to come and set int. Come and set int number, because you are asked to enter the number of students as an integer. So when you come and do that, you come now after this, you come and say you need a scan f. So it becomes percentage d, the format specifier for the integer, when you do and number. So you begin from that very point. So you have to run this piece of code. You are able to ask the user the number of students. So you can come and say 8. Okay? So at that point, just already got about 3 months. That's why it's that each step is important. So answer the question according to steps, not trying to just do everything at once. Okay? Then next, okay, for this case, in case you want to add or say something else, you go for the element of in case you want to check. Like let me say if the number is not greater than 0, you can loop again and try to ask the user again. But we won't look into that right now. Why we should look into it? Alright. So for this case I'm going to use a while loop. Okay? Because looping, that means that you want to keep on going back to that point until the user enters something greater than 0. So, select the while. So it is while, then you add the condition, while number is less or equal to 0. Means from this point, it should first of all print f say number is, just write invalid. Okay. Direct number is invalid. Come and pick this piece of code here. And add it within the loop. So at this point here, I'm being able to achieve the loop. That means from come and run this code here, the number of students, I put a 0 here. Okay. Say invalid, so it will ask for the number again. Maybe just to make the code more organized to look nice. I also add a given print statement here. Right, print statement here. That if I was to run this, you should be able to get in the number of students. I put a 0, invalid, enter again. I put a 0 again, you run again the loop, invalid, enter again. When I run, I put an option number now, then you should be able to proceed. How to get up to that point? So please raise up your hand. Because I think I'm going to help you as you go from there. Exam. So I think I've answered the first part of the question, right? How do you all have the question? Open it. Father, I'm doing this with you on your side. Yes, you have the laptop, please. Use the machine in the front of it, they have things stored. So, we have said that prompt should like the number of students in as an integer n that is greater than 0. Second thing is going to be using a loop, input each student's test score as a floating number, their test score. Student's test score as a floating number. Then you validate that each student score is between 0 to 100. If there is an invalid thinking, then you re-input the score. So as now I want to use a loop. If you have put 7 students, it should loop 7 times to get the max of those 7 students. Yeah? So if I'm looking at the 4 students, let me say, now put 4. So it should ask me what are her results. I put, let me say, 80. Put the next one. What's her result? I put 70. Next one, 50. Next one, let me say 90. Yeah? So as I'm inputting those marks there, if anybody let me have to put that she has a negative 2%, it has to give me invalid input and it asks me to enter her marks again until I put a mark between 0 and 100. Okay? Alright, so let's go for that. So I think here I shall use, remember I told you that you use a for loop, you know exactly how many times you want to loop through something. Then you use a while, you do a loop when you don't know, you just keep on to do something until. For example, why we use the while loop here? It's because you don't know how many times someone will enter an invalid number. And if you come to the example, like for the example, enter the pin 3 times. If it's wrong 3 times, lock them out. That one now becomes a for loop because you know the exact number of times you want to loop. But if I've asked that whenever someone does something wrong, just keep asking them again. Go for either a while or a do while loop. All that's clear. So here they're asking us to enter people's grades. So what do we do? I've said number 1 it should be in float format. So I'm going to have float, then scores. Yeah? By these scores here, I'm going to put it in an array. So whenever I declare a variable, let me say float score, like I've declared this. Once we add those square brackets, we're trying to say, whatever we're going to do is an array. Remember when we're trying to do the name thing, we're trying to make an array of characters to make someone's name, that's why we're trying to say that we have the char name, then we come and do something like this. And we enter here, let me say 280. Remember that? Yeah? So here we show it here. Oh, I mean, the thing here. Now for this case, we're trying to say we're going to have an array of characters, but it will have 20 characters. So the similar example here we're trying to do. We're trying to create an array of scores. Yeah? But I can be able to enter different scores marks. But now the case for this case, if we're using numbers here, we're depending on the number of students this person has entered. So if you put 10 students, yeah, the array should cater for 10 marks. If you put 20 students, the array should cater for 20 marks. That's why when we're coming here, what do we put inside here? We will put the number that the user entered. Because at the first point here, the user was asked to enter the number of students. So whatever they enter here is how long the array should be. So we have that. So the next thing we say is when you know the exact number of times you want to do something, you go for a for loop. Okay? So here we go for a for loop. So you come and say for int, let me say int I. You can use the name. Yeah? Is equal to 0, for example. That's the first thing. Then you come and say I should be less than number. Well, I say less than number, remember here I'm going to count from 0, 1, 2, 3, and so on. So assuming our number was 5, but you entered it what? You have 5 students. So here it will want 5 elements. So you can begin counting in the loop to loop. The first time 0, then 1, then 2, then 3, then 4, which is less than 5. Right? So we will now loop 5 times. Or if that is confusing, then you rather come and put here a 1, and you come and say this is less or equal to. How to get up to that point? Please, if you lost, you raise up your hand. Here alone, I've come to the to an individual. So in case there's a place where you lost, you raise up your hand so that we move together, okay? Alright, so we're saying that is that, then we want to say our I is incrementing. So after putting those conditions, then you come and now put in the loop what you want to do. So the very first thing I want to come and say is our print f. I want to ask the user enter the score of, I'm going to put here percentage D such that I can pick the exact part of whose marks I'm entering. But I can come and say here for students percentage D, here is going to be I plus then I can come and say scan F. Now remember, if I enter someone's score, declare as a float number. So what does the format specifier become? This percentage F. Then comma and scores. And score. So on score, but remember, score is an variable. Okay? So we have to put at that position I. So that's the first thing. So the next thing, we're going to go through what we call, for this case of this one, we're going to do what we call nested loops. So since we now know the exact number here, we're going to add a while loop within the for loop. So that we can have here while our scores of I is less than 0, then we add this or scores explain a bit. So, if we understood the first part, the main thing I'm explaining is this part, right? So what I'm trying to do here, the very first loop is the for loop. This is the concept of what we call nested loops. That person actually require you to have such things. So the very first thing here was saying that for I is equals to 0, then I should be less than whichever number we enter up that side. How to remember that? Then our I, don't remember. Do you remember? That means we have it here. So we're trying to say enter the score for the score. Enter the score for our student percentage D. Now why I put here I plus 1? Remember our I is beginning from 0. So I just want to print enter mark for student 0. Because it doesn't make sense. That's why I put here plus 1. Okay? So that means loop in the first time when it's 0, it is 1. When it's 1, it's 2. That it makes sense. But it doesn't matter. This is not compulsory. So you can even remove this. I'll show you another reason as why we left I as 0. I'll show you the next reason. So here, we're saying scan F, enter score for, then you open brackets. So this percentage F here is referring to the float of the array that we made. Yeah? So we are saying percentage F and score, now put in position I here. Yeah? What is happening inside here is that we're trying to say that for the case of this, we're trying to get the score, the scan F, and what we're trying to enter is for this exact array, but at position 0 for the very first time. Now why we left this as a 0 is because, remember I put here a 1. Why I put it back to 0 is because, remember the way arrays are. So if you have arrays, you have what we call indexes of an array, and the indexes begin from 0. So that's the main logic. Let's try to begin with the 1 here. As long as you come here, you're going to have to add the minus 1. Are we together? Alright, so that's that point there. So this one here will keep looping for the very first one, index 0, index 1, index 2, until it reaches the last number that you're putting. But then, why we're adding a second loop here is because remember, we're trying to say, for the case of the while loop, you only loop the while loop when you know how many times you want to loop. But you can also use a for loop if you know the times. Otherwise, you use a while. So, for the case of this while, we're trying to compare, because remember the question asked us to check if the number you have entered is less than 100 or greater than 100. That number becomes invalid. So the question was like, question is like, it prompts the user then using a loop, input each student's marks, test score as a floating point number. Validate that each score is between 0 to 100. If it's invalid, prompt until the thing is valid. That means here you come and say, why we are saying this is for I is less than 0 or for score I is greater than 100. So if it's less than 0 or it's less than 100 or bigger than 100, we are going to print invalid score and we should enter that given. And we enter that exact invalid value of I. Okay? So I think that's, have you understood that? Everyone. Let's run this code here. Let me just add this inside of it. You can ask for that person's thing here again. So you can come and run this. You ask how many students. Let me say there are 4 students. Say enter. enter for student 1. Let me put here 120. Are you seeing that? Gives me the valid score. Enter the score for student 1 again. So it stays in the loop. So the trick here we're trying to do, we have a for loop, then inside the for loop we have a while loop. So remember the for loop has to finish totally before it goes to the next input. For to add a while loop inside there, that means the while loop should also, the while loop is under the for loop. So the while loop must be successful before the for loop says I finished a successful revolution. That means as long as I put a condition on the while loop that the number is bigger than 100 or less than 0, stay and do the same thing the for loop was asking for. That means you stay inside there, inside the while. So when the while is successful, when the for loop can try to do another iteration. So that's what we're trying to do basically. So can come and enter here 45, ask for 267, then this, then let me say that. Okay? So at the end of the day, I've been able to achieve entering all the marks for the given number of students. So the next thing I want to look at now, the question is asking us to store all scores inside an array. I think we've been able to store that already. Okay? That part is already also done. So the next part is going to ask us, write the following function. Number 1, we need a float. Compute average function that takes in the float s of an array kind of thing, then int n, then it returns the class average score. The next thing we have a void find height low. That means look for the highest and lowest values literally. So the class begins with the very first one that is asking us to compute the average. Oh, you must print the scores. Maybe that would be they actually pick the scores of it. Let us leave the for loop. And we go and say print scores. We put it up here such that when you come and do this, we are able to. Now, as long as you're dealing with arrays, just know you'll never escape loops. And if you're scared of loops, just begin practicing them. Because they are surely questions on arrays in the exam. So there is no go around. Okay? So to learn how loops work, go to YouTube, watch videos, do everything you can to be able to get how to write loops. So the very first thing I want to now do for a for loop again. So we shall have int I again. J. J is equals to 0. So our J is going to be less than our number. After having that, our J is going to be incrementing. Okay, and come here. Now print, so we shall come and say print f. Come and do this, come and say percentage. You know how to do these things here. In case the place that you want the value into decimal places, you should be able to add that dot, the number of the then you add the comma specifier at the end. So from there we shall have that, we shall come and say comma, picking the scores. Position J. We have 3 students. First one got 88, one got 97, one got 79. Okay. 97, good. 79. Okay. And that's going to see why we are getting this. So control there. Someone look at this. As our percentage, refer to it so much, specifier. So in case of run this, let's try again, enter. We have 3 students, 98, 88, 88, 79. So we are printing here 98.00. Since we asked for decimal places, we are printing 88.00. We are printing 79.00. And let's try to make it more organized and print which thing we want. Add our slash n. We run this code, we should get. So there are 2 students. So there are 2 students. So student scores, the first student has an input, next one has 56. So with that, we're almost done with the question. The next thing I want to answer is now to write the given functions and perform the different tasks. Okay. So I remember giving you some piece of idea. Whenever you're going to write a function, to avoid adding anything before the header, come and write your function above the main function. So the very first thing was to plot by computing our average, right? So on our average, we come and say, so that taking a float S, that's some kind of array of floats, and shall come and take in our int, which is what? Number. Open these brackets here. So, which type of function is this? As long as you see us beginning with something like this, float or int, that becomes a return function. So from that point there, I shall come here. Since we have added the parameters, I'll come to our function. We shall come here and come and say our float sum is equals to 0.0. Who remembers why we do that?
I think because if you don't initialize the sum to 0, the computer will bring its own garbage value.
Exactly. So if you declare a value and don't give it a variable and don't give it a value, the computer by default gives it its own value. So you have to be deliberate since you want to calculate an odd number. So you can come and say our sum is first of all at 0, 0. So I told you, as long as you're working, you don't have to learn loops again. So if you come and say for our int I, what equals to 0, you come and say our I is less than the number we are going to put. So I is less than the number. Let us see our I is going to be incrementing. Okay, so inside the loop, we're going to come and say our sum plus also s brackets I. Okay, but this is the short form of trying to say that our sum is going to be equal to sum plus that. Maybe we use that or wait. Okay? So this is what we're trying to say. Then you come into some function at the end here and return. We return our sum. So maybe to explain this a bit, what is happening? We declare a function, which is a float type of function. So return type of function because it doesn't return something, but we're using float, compute average. It has two variables, taking a float number, a float array, yeah, and an integer number. So I've declared that our initial sum is going to be 0. Now the for loop here is trying to tell us that we're going to look through this number. Why have I left here as number? Because we're going to be using the number of the students here to look through an array. That's why I left it the same here. So you have for I equals to 0, I is less than our number, and I is incrementing. So here what we're trying to mean is that, remember I told you last time when we were going to do a crash course, if I declare a variable up, and I say, let me say int number is equal to 6, yeah? Then the next line I come and say, number is now equals to 7. We take, and I print number, we take the most recent one. Because see, the language that goes step by step through what we call procedural programming. As you go on in your course, you will learn object-oriented programming that gives us different classes and so on. So for this case, we're trying to say that our sum, that first of all 0, remember, before it enters this loop. So now I say that our new sum is going to be what our sum was, which is a 0 plus the s at the point I. So after filling this other loop inside, you come here. Inside this array you shall have those given numbers. So we will pick the very first number and get 0 to the first number of 98. We will get 0 plus 98. Then we will leave this loop. Come the second time, loop that to position 1. That means our sum at this point, the second time is now 98. That means listen that now our new sum is going to be now 98 plus the next number. Make sense? Okay. So from that point there, so we come to look here. Why you put and then you call the function. How do you call a function? Compute average.
First, you kind of then you call it then you put which put it right? So you say, for example, average is equal to, then you put average into the
Sorry, we're going to bring average. What do you compute average? You open and put the given value that you need. That is the one.
what you do is you use the number.
how is it supposed to be debugging? Yes.
When you come from the sum, you also then have the main function. Return the sum, it's supposed to return all the complete stuff. You have to return the sum, so the function. If you're computing
Thank you for that. Thank you for that. Yeah, and what? That right? That gives us the average. So when you run this, should be able to. How many students do we have? We have 3 students. Number 1, Matthias put 73. Next person got 84. Stacy got 67. Hey, wait, the work in the thinking. Hey, you have to print it. What's in the okay. So when it comes to this, supposed to be able to print. So print F should give us x4 percentage F decimal places. Then I should be able to print and pick it from average. Okay. So how many students? We have 4 students. 78, 67. We run that, supposed to come and pick those numbers, then we print our average score is 7, the 2.3. We all together? No. The noise here. Okay, so what we are trying to do here, we were asked to write a function that computes the average. Okay? So what we did, I told you I can never write in a function, try to write it above the int main. Because if you put it below the int main, you're going to have to add some kind of headers here to show that you have a function now on that side. So to make life easier, it is above the int main that you don't have to go through that hassle. So our function of computing average is this. So we are saying that we are computing average, yeah? But since we are computing average, our average is for computing. So now, first of all, number 1, pick a float value. Here we put here S, an array. So here what we're trying to just describe is that this is going to be picking an array. Okay? We are together? Okay. The second thing is going to be picking an integer. The function is picking 2 values, an array and an integer. Those are 2 values. Then you should come and say our float sum is equals to 0. So we're trying to say that by default, first of all, we shall make our sum of all the values in the array be 0, first of all. Yeah? That will first of all be 0. Then we're trying to say that as long as we have now a for loop to begin from 0, it has to be less than the number you put here, and I is incrementing. So I say that our sum position is 0. Yeah? It's going to become equals to that sum equals 0 plus the value which is in the array at point number 0. Remember how arrays work. We have the indexes, index 0, index 1, index 2, index 3, and so on. So we're saying at the first point we take index 0 because I is 0 first of all. That means our new sum, let's assume that we have our S here, it has 90, 80, and 70. Those 3 values. You have to assume. Yeah? So at that point, we shall come and say our sum is going to be equal to 0 plus the first value at index 0 is 90. it becomes 0 plus 90, so our new sum is going to become 90. So as long as this thing is, this thing is coming out of this loop here, he has gotten that our sum is now 90. When it comes to second time, what will be at point 1. So when I is equal to 1. When you enter, this will become, now our new sum is going to be equal to the old sum, which is now 90, remember. So 90 plus s at index 1. So it's like, say that the total sugar is 80. Yeah? So it will become now 90 plus 80, which is 170. So it will keep doing that until this loop is done. Yeah? So at that end, we'll have total sum. That's the sum of sugar is 90 plus 80 plus 70. That is 240. Okay? So, besides this is the return type function. So when we return, we shall return our sum divided by number. What is average? Average equals to the sum of numbers out of the number of numbers. A sum of items out of the number of items. That is basic average or basic math. So our function knows it expects an array, it expects a number, yeah, and it expects those two things to be able to run. So I don't need to grab the x's number, that's what okay, say that. Let me assume this is x, okay? Just look at the put here, divided by x. So our array, our function expects an array, number 1, it expects an integer, general, okay? Okay, then we came back here, we are now calling the function. And when you call a function, you're supposed to assign it values, right? So here we call it, we just get the right name that plus average equals to, this is us calling the function, compute average. Now remember, it expects an array, 1, it expects a number. But remember, as we write in our code, we're picking students' marks and storing it in an array called score. So since we already have an array called score, that's why when we come down here for the input of array, we just give it score. Because it's an array that exists that is called score. Yeah? Then the number here. Now this score here, I know it has the number, the marks of all the students. So if you put 10 students, you have marks of 10 students there. Yeah? But remember also at the beginning we were asking for number of students here, and you enter the given number of students. Since you enter that number of students, we just put here number. So now given the array, that was given the array, an array, the function, given the function an array, and given it a number. So it can compute based off that. That is why when we call the array this and try to compute the array, it gives us the exact average, because we need our own array and our own number of students. Do you think that? Okay. That is it. Okay, that's the very fast point of everything. Okay. Now the next part of the question asks us to there was now write a void function, right? That finds the highest and lowest mark. So to come back here, again above the main function here, is where we can add void. The same add a void function called find high low. So come back this side and come and say void find high low. Okay? And come and set plot. Can use the same thing to show that we're expecting an array again. Right? So we expect an array and we expect, let us make your brain think. We expect an integer. Like two things we expect, right? So let me make your brain work now. Here I did everybody that creation. So no one gives me an answer, I will think you are trying. So we have these 4 people here. Yeah? Let me say she has cram your mark. You have 90, you have 80, you you have the 85, you have 75. Okay? 75. So these are the 4 people, they have marks. So let's assume you don't know their marks. How do you determine who has the highest mark?
So I would initialize the highest mark to one of the students. I would assume one of the students has the highest mark at the beginning. Then I would check the marks of the other students and compare it with that student's mark. If they have a mark that is equal to that student's mark or greater than that student's mark, then that would become the highest mark.
That's one way. Another person. That's what what is trying to explain. Yeah? So if I have 4 of them, yeah, and they have so what we want to do, we are going to assume that this guy has the highest mark. Yeah? Remember, we don't know all their marks. So we shall come and say, okay, this guy has, let me say he has 75. Very good. That was your mark. So we'll assume that he has the highest mark. So I will move that. The highest mark is this guy. So you keep moving and you go and ask her, what was your mark? So 80. So I assume that her 80 mark is higher than his mark. So the new highest mark becomes hers. Go to the next person. What was your mark? 90. So her 90 is greater than this one here. So she becomes the highest. So you come and check with her. How much was 85? So the 90 is higher than 85. So we stay with this 90. So we're going to achieve that. We're going to withdraw a loop. The assumption part where you come and say the float. So this is our highest mark. Okay? It's going to be equals to at position 1. And when I write this here, I'm trying to refer to the array, we're trying to be clear. Okay? So as soon as the very first mark in the array, assume it's the highest mark. The same thing with the lowest. The very first mark in the array, assume that it's the lowest mark. After you come and say equals to S at 0. Okay? So what do we do then? So you come and now look through the whole array. Come and say 4. Let me say int k, never used I, is equals to 0. We shall come and say our k is less than n, obviously, and our k is going to be incrementing. So after doing that, we shall come open our loop. So we shall come and say if with the part of comparison. So if our s at position I is greater than our highest mark, what do we do? We shall come and say highest mark. Okay. Then we shall now add another if statement for them. So, I'll come and set if, open our brackets, if the same I is less than our lowest mark. What do we do? Lowest equals to yes, position I. Determinate.
Yes, please. But if I decide instead of initializing the highest and lowest score to the score of the student in index 0, I decide to initialize the highest and lowest score to 0. Instead of saying before highest score is equal to S index 0, so the highest is equal to 0.
Who am I looking at? We're just checking the numbers. Why we are assuming, okay, you can work together, why we are assuming this is because remember you're going to look through an array. So you have an array is square bracket, you have very many values to say there. Yeah? So why you are assuming that the thing is at a point is because when you're writing your code, you're going to look this one. Let us try one to see them. Let's try this.
I want to believe that if, for example, SI, the value of SI, because the computer is going to interpret it as a value of whatever is in SI, is greater than 0, it's going to automatically replace it, and then highest will now be an array.
I must have running differently. So maybe do it out there first of all. If it works then why not? So we are going to ask just print within the equivalent to done the method.
Why are we using I instead of K?
Why are we?
Using
Hey,
I
sorry.
instead of
My head is used to I. Okay. So we are coming down here. What do we do? We just call. How do we call a function? A void function. So it expects an array again, so we give it our array of score, and it expects an integer, so we give it number. So the one is the code, and we have errors. Expected right, okay. Like that doesn't make error message. Something you can be annoying.
Then the number,
When
it's
down you use the
14.0, I use that number. Just the one.
you say
So much weight.
You change it.
Yeah. scores as this. The highest mark is 89. The lowest mark is, yes, I think the highest size. The lowest mark is 45. So I think we should get the print statement.
That's when the highest. Sorry, proportion marks.
So, I see that one of code. How many lines are these? These are 61 lines of code. So on average, you may have at least 61 lines of code in your exam for each question. Yes, the way to use this. Because the way to shoot and it means the way to shoot it. Very many things. Suffer with your problem. I also have problems. So, I guess now you answer a question. So, someone who stopped at actually before writing these functions here, you may find that has already put in even 10 marks. Okay, so we have to just keep gathering marks as you go on. 11:41, finish. Okay, choose one number between the remaining two numbers, then should I help you with the number of pointers? Then there's number 3 for statistics. So you're going to go to enter the number of people in the household. Each person input their age. I think this last number is similar to the first one, right? So we do the pointers here. Okay. If I'm just new here, you just like this up and okay. That's two pointers. I hope you guys remember the whole way pointers work. Because we're going to base exactly off the hex. Okay, so we have our header file and we have that. So the question goes, developing a small utility tool for data entry, clerk often enters values in the wrong order. To help correct input mistakes, write a program that swaps two numbers. So the requirements, write a program that prompts you to enter two integers. So it's very easy. Okay. Print F. Enter. First integer. here, I think this one is obvious. Entering the two values, the points whereby we shall have to begin serious things is the element of swapping. So, when we speak about swapping, what do you understand? Let's start from there. Hmm? Anyone? Before we do this, let's go back to this slide. Do you remember this slide? Do you all remember this slide? Some of each of the class that day. So we say that we did with pointers, we're thinking about their storage space in memory. Yeah? That's how pointers. So here we have an example of code. Yeah? We had int x, y, x equals to 4, y equals to 10. As you can see here, x, 4, y, is 10. So next we declare a variable, remember, it's stored in the memory location. So last time we assumed that your x was stored in the location 100, okay? And your y was stored in location 102. We call memory addresses. Yeah? Are we together?
Yes.
Alright, so come and start. If we change the last printf statement to print percentage d, y, what is the output? Now b. Okay? So we have this as the answer. So the and in front of the variable y is the address operator and refers to the address of the variable y. So remember when we do scan f, in case what we try to you do like whenever we do scan f and we come and add that and symbol, what we're trying to change within that is going to be the address. Remember, we come and say int x here. Yeah? Before we assign a variable and say int x and stop at point. You may store it at that point. But since for this means that you input the thing, we're trying to start when we are doing a scan f, and so like it as a value, you go to exactly that memory address. That's how you normally add an and when we are doing a scan. That one was free. So you come and say the and in front of the variable y is the address operator and refers to the address of the variable y, and therefore we need to print the contents of the variable y and not print the address of y. So this is the first fundamental step to understand pointers. So at least what we call addresses or locations where these things are stored. That's the very first point. The next point we're trying to say is to summarize the address operator. Y refers to the contents of the variable y, and y refers to the address of the variable y. So the first one refers to the contents, next one refers to the memory address. So when you come and say that int x, y, okay, remember it's stored this here and stored 10 here, assumption, okay? So when we come and say that int, put a star and p becomes what we call a pointer variable. Okay? So any variable that you declare and you add that has steric sign, or that hash sign before the variable, that becomes a pointer variable. Are you prepared?
Yes.
Okay. So I'm trying to say that in front of p tells the compiler to create a pointer variable. The pointer variable is used to store the address of another variable or variables. Don't store values in the pointer variables. So p and x stores an address of variable x into the pointer variable b. Who can explain that? How I have always you're lost. Okay, so we're trying to say that I think that the way I've written this, we're trying to say that in case of make a pointer variable, you don't have to get part. As long as you put a asterisk before any variable, that becomes a pointer variable. So we're saying that the this in front of the p tells the compiler that to create it as a pointer variable. Fine, is okay. So a pointer variable is used to store the address of another variable. It's used to store what? The address of another variable. Okay? That means as long as we are saying that this p, is equals to, that's what's going here. So we don't store the value in pointer variable. So p equals to, and x stores the address of the variable x into the pointer variable p. So this p refers to the pointer variable that points and the pointer variable p is pointing to. So in this case, our p value contains the address for x. For x, so we're coming from here. Therefore, it is pointing to the variable x. So we can say that asterisk p is the same as variable x in that point. So p equals to 4 doesn't mean that it stores 4 in the variable p. You use the pointer variable to access x directly. Okay, let me use analogy of folder. You've already used the laptop before, or a computer. So you have a folder, yeah? Go open your, let me say about this D, open a new folder there. The basics of how a pointer is pointing. Place your graph. So for this case I'm going to use so this is what we're going to do. In my case we're going to use a function. Okay? The function responsible for swapping. So I'm going to have bare minimum first of all I'm able to get two values from the user. So I'm going to get the function. So I'm going to take up here, I'm going to use the void function. So I don't have to return it, just print the directory. So let me say I have void equally swap. This was swapping two numbers. Okay? So this is going to take in two values. But the value is going to have to make them pointer variables. So we shall have int, then you have our asterisk a, comma, int, then asterisk b. So what I'm trying to tell the compiler at that exact point is that we have two pointer variables. That means whatever we give them to, they're pointing to the location of, they must point to the locations of other variables. So a and b are pointers. Number two, we are going to have what we call it, I'm going to call it a temporary variable. So I'm going to come and say int we have temporary. Yeah? Then we're going to come and say it's equals to, we're going to assign it this. Okay? So, with x and y and then between x, y, then I, then j. So that means that our int temporary. Now temporary, remember, is a real, like you declare a real variable. Okay? But we are pointing it to that this int temporary should be the location of the memory address. Okay? So from that point, we will now come and do, this is where the whole, I will call it the whole swapping happens. Yeah? So we come and say, in the address where there is A, where there is A, where there is A, we are going to put B. Okay? Then, in the address where there is B, we are going to put temp what? That way. So, let's explain these things here. I'm going to go back to my thing of folders. So here we have, let's assume there are folders. I have a folder A and a folder shortcut to folders A and B. Okay? But then I come and make a new, let me say a new folder. Yeah? But it's pointing to the shortcut A. Okay? Are you together? Yes. Jesus inside everyone. So, if you come to this, you come and say where the shortcut A is. Yeah? Enter shortcut B. And where shortcut B is, enter temporary. First of all, store temporary and shortcut A. So you have two, come back to this thing. You have two flash drives. One has content of, let me say there are 2 GB, 2 GB, both flash drives. Now, you want to transfer everything in flash A to flash B, yeah? And everything in flash B to flash A. Remember, both flashes are full. So what do? You first pick flash A in your computer, transfer everything from flash A into, let me say, your PC. Okay? Now there you have everything. Flash A in your PC. So you can delete everything within flash A. So at that point, flash A is empty. Okay? So now you can pick everything in flash B, go to empty flash A. Now you pick whatever you put in the folder in your PC and remove what was in flash B and put what was in your PC into flash B. That's the best way I can explain this swapping concept. Then I'm still confused. Yeah? I'm confused. Okay. What do I do in here? I'm going to give a stupid example. I think you'll understand. So, I have him, I have you. So if I tell the two of you, I need to give him your shirt, he gives you his shirt. Now, what you will do, let me show you number one. Now you have one, you have pointer A. Yeah? This pointer B. Okay? So, subject. So, what will happen? I'll come and, this is your pointer A. I'll come and give you his jacket. And I tell you, I'm going to give you your shirt. What you can't do is remove your shirt in class, I can give it to him. So I'll give you this, first of all. keep removing. So you go remove your shot, which is pointer A, not existing anymore. Yeah? And put on this. Now that point here, since you have something you've stored, you can give an exchange now. I mean, you give him your shot and he takes this shot. Exchange is now possible. Because you don't want to lose the data. I don't know if I'm trying to explain. I'm trying my best really. So at that point now, after doing that, when you can now go back where the shot and return back is jammed. So what I'm trying to do, we have a new variable. Then go to the yeah. So I'm trying to say, in case you have, let me use bottles now. I've used what you have 3 glasses. Yeah. One glass has juice, another glass has water. Yeah. Another glass is empty. So until I have to change the glass which has juice, put in water, and it has water, put in juice. You see it's high, that's what they do. So you need a 5 glass. They took the 5 glass, and I pick the 5 glass, I must pour my water. That's that empty glass. Now, the glass is empty. The water is still there in the same glass. So I pick this juice now, I pour it into the water. Now, after, now I now have juice in the glass. I have juice in the glass and water. So one swap has happened. Now the second swap, I have to go back to the last 5 now water, say 1 now water, they can water. Going back to the glass and juice now. So they are now the swap. Are now good? Okay, so that's exactly what we're trying to do here. We're trying to set, we have a pointer, which points to the memory address of task A, yeah? Then the memory address of B is this. So we say when we have pointers, what does the pointer do? Sorry. We say it here, yeah? The pointer, which is something that is hash, yeah? It references to the variable that the pointer variable B is pointing to. So it's like a reference point. So when we come and say that in the memory, wherever you see this wherever we are seeing this in temperature here, yeah? We're trying to say that by another variable called in temperature, and we're pointing it to the memory location of this. So here we are swapping memory location. We're not swapping the variables themselves. We're swapping locations. So we're trying to say this A is pointing to a slot where we had temporary. Then, now since we have A and B, 2 things, yeah? I want to do that now, whichever address was at A, memory address, yeah? I want it to be given to B. Now remember, B had this address, but since we've done this, I'll simply wipe that. Okay? And now A is in B at this point, so that's what has now happened. And remember, we have stored our A somewhere in something called temporary. That means when we come to this point, I'll come and say our point at B is not equal to temporary, which was equal to A before it swapped. When that's good then. And I can't help you further. Okay, so we have that. So we have 2 print statements, yeah? But the very first one we're going to have and send print F, which shall come and say here, so before swapping. So before swapping, come and add the slash N here. Before swapping, shall have that. So, come and give them here. Percentage D, comma, D equals 2
before swapping.
Yes, sir. And you shall come and say, comma, you're picking what? X and Y. So X, comma, Y. So, this is before. But yeah, we'll just pick the values and we print them directly. So now we shall now call our function responsible for swapping. It's a void function, so we just have to call its name, assign it the values. So assigning it at this point, we're assigning it what? What are we assigning? When we were printing last time, I told you do a print and you add the and symbol, printing it back to the memory location from address, not there. So the pointer, the function up is expecting these to be memory addresses. Because you don't change the contents, you just switch memory addresses. So the contents should remain the same. So
Hey, as you're here, computer science students, check your alpha. Essential marks are out. Before today ends, because he's making corrections.
So, after doing this, the last thing we have to do is simply reprint this. So, as long as we have this, we run our piece of code. That's us for the first integer, say 6, 7. So, first swapping our A is 6, our B is 7 after after swapping, it becomes 7 and 6. So that's basically how we swap. Yes.
You told us if you go back to the function.
That's the second one.
If you go back to the function, it's not returning.
The void function.
Yes, it's not returning. But then it's not returning. Why is it that the address is there, the numbers are being swapped? Why is it that the numbers are being swapped? The void to get this
Because the void function just do whatever you put in there, so you don't have to return. So that's why we might even put it in this. So in case I to bring anything up here, you have to write up this side. And I just watch.
Okay, so if you're looking inside the void swap function, how would you